Hey guys, this is Mr. Randall. When we met the support teachers, we decided to provide you with information that you're going to need to, of course, not to help you in algebra, but not only to help you in algebra, but to help you throughout the mathematics that you'll have for the rest of your career at Langston. So we're going to start with equations, and because you'll be solving equations in algebra and geometry and algebra 2 and pre-cal and AMDM and any other mathematics that you take. So we're going to look at that, and it just so happens that your algebra assignment for this week is also solving multi-step equations, so kind of ties in with that. So a few things we're going to look at today. We're going to look at equations, the golden rules of equations. What are the main things that you have to remember? Some of these you got very early. You got in 7th grade or 6th grade. Some of these I'm going to say you may have never heard before. Then we're going to look at different types of equations. We're going to look at multi-step equations. We're going to look at equations that you have to clean up first. And we're also going to look at what's called literal equations, and we'll talk more about those in a second. So let's roll on and get started. Our first thing is, what are the golden rules of equations? And there are a few. The first golden rule of equations deals with that thing that makes an equation, that thing called an equal sign. So let's go here and put an equal sign there. And the first golden rule concerns that equal sign. The equal sign in an equation is like a fence. It is something that you cannot move things across. So you can't combine like terms over an equal sign. You can't put two things together on different sides of an equal sign. The only thing you really can do is erase things that are on, or get rid of things that are on one side of an equal sign. So we're going to start with an equation. That's your rule. So we're going to start with an equation. Let's start with a simple one. 2x equals 6. That is a very simple equation. That is a one-step equation. We know it's an equation because it has an equal sign and it has things on both sides. So it's saying one thing is equal to another. So the first golden rule, of course, is I can't do anything across the equal sign. The second golden rule of solving equations is that every time I do any step in solving an equation, it's designed to erase something, to get rid of something. So my first step that I'm going to get rid of here is to get rid of that 2, right? I'm going to get rid of that 2. And how do I get rid of multiplying by 2? I get rid of it by dividing by 2. We learned that in 7th grade, right? So that's the second rule. Everything that I do is designed to actually remove something, to cancel something out. Well, the third rule is that whenever I do something on one side of the equation, I have to do the same thing on the other side of the equal sign, the other side of that barrier. So on the left side, I divided by 2, so I've got to divide by 2 on the right side. Whatever I do on one side, I have to do on the other. So since that cancels out, I get x and I get a 3. So my x is by itself. And of course, the last rule of solving equations is when the equation is solved, you have the variable that you're looking for, the variable that you're solving for, solving in terms of. You have it by itself, and everything else is on the other side. So this equation solves to be x equals 3. 4 rules again. First rule is that the barrier is your equal sign. You can't do anything across a barrier. Second rule, every time you do something, you should be trying to eliminate something, to get rid of something. Third rule is whatever you do on one side of the equal sign, you have to do on the other. And the fourth rule is that when it is solved, your variable that you're looking for, that you're solving for, is by itself. So those are our 4 rules. Now let's get down to some gritty and some nitty. Let's start with where we are this week in algebra, multi-step equations. So I do these a little differently. I'm going to add a step in here that you may do, you may want to do, you may not want to do. There are a lot of different ways to solve equations. I do things to take a lot of the thinking out, to make a lot of it just reaction. So my first step, the first thing I do is to create that barrier, and that barrier is that equal sign. Nothing can go across that equal sign. And then the second step that I do, because a lot of people do that one, but this is a randolism. This is something that I like to do. I decide which side do I want my solved variable to be on. Do I want it on the left-hand side of the equal sign, where it will say x equals something, or do I want it on the right-hand side where it will say something equals x? Either is fine. Because most people choose the left, this time I am going to choose the left, x. So I put a little x over the left-hand side of the equation because that's the side I'm solving to. Everything else is going to be a reaction for me. You're not required to put that x over the left-hand side or the right-hand side. For me, it just helps because now it tells me what my next steps are. So now I just get to figure out, well, if I want my x on the left, then that means that 5 isn't supposed to be there. So I circle it. And if I want my x on the left, then that 7x isn't supposed to be on the right. So I circle that as well. And since I've circled both of those, and everything else, there are no x's anywhere else and nothing else on the side with the x, then I gotta remove some stuff. So to get rid of plus 5, how do I get rid of plus 5? I get rid of plus 5 with minus 5. And the third rule says if I put minus 5 on the left, I have to put minus 5 on the right. If I want to get rid of 7x, if I do 7x with minus 7x, if I put minus 7x on the left, I have to put minus 7x on the right. And then watch how this cleans up. Well, what happens to the 5's? Well, the 5 and the negative 5 cancel out. Second rule. The 7 and the negative 7 cancel out. That's a rule. So now all I have is 3x and negative 7x on the left. 3x and negative 7x gives me negative 4x. 3 and negative 5 gives me negative 2. And I'm back to where I have a very simple equation like the first one we did. So now I divide by negative 4, divide by negative 4, and I get x on this side, and I get negative 2 over negative 4 on that side. X is by itself. So x equals negative 2 over negative 4. Well, that reduces, doesn't it? That reduces to x equals 1/2. Should I change that to 0.5? No. My personal preference, Mr. Randall's personal preference, is to leave it as a fraction. There are reasons for that go beyond what the scope of this is. That's what I like. So let's leave it as 1/2. Let's go to an uglier one. This one, wow, it doesn't even have an x, it has a y. Oh, so what? It's still a variable. So I still have the same steps. I draw my barrier. I decide what side do I want that y to be on when it's solved. Well, last time we did the left, so this time let's do the right. Y, I want y over there. And then the rest is reaction. But I can't start getting rid of stuff first because it's not cleaned up. It's messy. So I have to multiply with my distributive property over here. I get 10y plus 5. I multiply with my distributive property over here. I get 56y minus 21, but I also have that minus 9. Now, what's in the wrong place? Well, if I want my y on the left, then the 56y is correct. But this shouldn't be there. Well, why didn't I put those together? Those are like terms. I don't really have to. Well, what about on the right? I want my y's to be, and what about on the left? I want my y's to be on the right, so this 10y is in the wrong spot. So how do I get rid of it? How do I get rid of 10y with negative 10y? Well, I got to put negative 10y here. How do I get rid of negative 21 with positive 21? So I put positive 21 here. How do I get rid of negative 9? With positive 9. So I put positive 9 here. And the 10y's cancel out. The 21's cancel out. The 9's cancel out. And what do I have? On the left, I have 521 is 26. 26 and 9 is 35. I put all three of those together. On the right, what do I have? 56 minus 10y is 46y. And I'm with an equation like the first one. I want to get y by itself, so I divide by 46. Divide by 46 because that's the third rule. My 46's cancel. Rule 2. And I get 35 over 46 equals y. Do I change it into a decimal? Do I make it in, can I reduce it? Well, I can't reduce it, and I don't need to change it into a decimal, so I am now finished. That is a nice little ugly fraction there, and so I'm done. Great. Okay? One more, and then we're done. We're going to look at literal equations. And like I said, what are literal equations? Literal equations are equations where there is more than one variable, or sometimes there's no numbers whatsoever. So, I don't like that. All right, let's go back here. I'm going to do the same thing. I'm going to put my barrier, and this time it's already solved for P. So, but I don't want P. This time I want to solve for what? Let's solve for W. So I'm going to put my W on the left and circle it, and then I go through the same motions as before. What's in the wrong place? Well, if I want W's on the left, my 2L is in the wrong place. Is there anything in the wrong place on the other side? No, because I don't have any W's over there. So the only thing I have to do is get rid of 2L. So minus 2L. Minus 2L, rule 3. That cancels out, rule 2. So I have 2W over here. 2W. And what do I have on the left? P and minus 2L. So is that minus 2LP? Is that minus 2PL? Is that, oh gosh, I don't know. Those aren't like terms. So how do you subtract them? Well, since they're not like terms, you don't have to worry about it. You just go P minus 2L. Wow, I don't have to do the math there. That's great. And so now I have to get rid of the 2. So I divide by 2, divide by 2. That cancels out. My W is now by itself. So I have P minus 2L equals W. But P minus 2L divided by 2 equals W. The answer could be there. Or the answer could be, if I simplify the fractions, W equals P over 2 minus 2L over 2. My 2L's would then cancel out, and it would be P over 2 minus L equals W. I'm going to circle both of these because either one could be correct depending on who makes the test and what answer they want. Both of those are correct answers. But remember, 4 golden rules. Your equal sign is a barrier. It's a barrier. You can't go across it. Decide which side you want your answer on to solve it, and then get rid of stuff. Circle what you don't want, figure out how to eliminate it, and then you're down to a one-step equation. Okay? If you have any questions, you can upload them to the team site and we will try to answer them. But I hope this helps. Have a great day, and we will talk to you soon.